In this video, we'll first have a look at Lake Baikal's key geographical features and see how it compares to other Great Lakes of this planet, before diving deeper into its origin story and its extraordinary anomalies. Chapter 1. Lake Baikal in numbers. With an area of just under 32,000 square kilometers, or roughly the size of Belgium, Lake Baikal ranks as the 7th largest lake in the world, just after the Caspian Sea and the North American and African Great Lakes. But where it lacks in surface area, Lake Baikal compensates in depth. Lying at an elevation of 450 meters above the sea level, the deepest point of the lake bottom reaches to almost 1,200 meters below the sea level, giving Lake Baikal a total depth of 1,640 meters and making it the deepest lake in the entire world. This combination of depth, area, and steep canyon-like walls have collected an immense volume of water within the lake's boundaries. Coming from the south and east, the Selenga, Bargosin, and Upper Angara River are draining a large chunk of northern Mongolia and the Russian Republic of Buryatia into the lake, giving it a volume larger than all the water in the American Great Lakes combined, and constituting 22% of all surface freshwater on planet Earth. While lying on the southern outskirts of the Siberian tundra, the climate around the lake is no less arctic. Winter temperatures average a quite uncomfortable minus 21 degrees Celsius or minus 6 degrees Fahrenheit, with a summer average in August barely surpassing 11 degrees Celsius or 52 degrees Fahrenheit. These rough climatic conditions, paired with the mountainous surrounding of the lake, are a big factor for the seemingly complete absence of significant developments around the lake. Only 40 towns have sprung up along the over 2,000 kilometer long shoreline, with just a single one of these reaching over 20,000 residents. The ones that do permanently live here have often done so since the early Iron Age, like on Baikal's largest island, Olkhon. Around 1,750 Buryats call this rocky outcrop their home, practicing shamanism and Buddhism far away from the stereotypical Russian culture. The land they live on, with 800 meters steep drops plunging from the highest point of the island into Lake Baikal, is also a perfect depiction of the tectonic past of the region, which has created this natural wonder in the first place, bringing us to Chapter 2, Lake Baikal's creation. The topographic composition of Earth's surface is constantly changing, but in this never-ending dance of the elements, with erosion from wind and water, the unstoppable march and retreat of glaciers, volcanic eruptions, or even human activity, there's one shaping factor like no other, and it's this one which stands behind the creation of Lake Baikal: plate tectonics. The typical map of the world's plate boundaries used for studying in schools is typically a bit of an oversimplification, with many microplates and rift zones being left out, especially around the Pacific Ring of Fire. Incorporating these as well, however, quickly reveals the tectonic activity which has shaped these inner Asian mountain ranges and Lake Baikal. Around the northwestern boundary of the Amurian microplate, a combination of divergent and transform plate movements are separating it from the Eurasian tectonic plate with around 4 millimeters per year. The combination of these motions is the cause for regular earthquakes in the region whenever the fault zone slips from the lateral movement. At the same time, the divergent movement thins out the continental plates along the rift, significantly increasing the occurrence of geothermal features around Lake Baikal, which is one of the primary tourist attractions of the region. And major earthquakes which have devastated parts of Russia, Mongolia, and even China can be drawn back to this plate boundary. With the advent of GPS, the speed of the plates can be tracked quite accurately today. And knowing that the divergence occurs at roughly 3 to 4 millimeters per year, the creation of the lake as a whole can be traced back to around 25 to 30 million years ago. This has also been confirmed with deep boreholes into the lake bed, where millions of years of sediment strata have been unearthed, which also gives detailed insights into the climatic developments of the distant past. With this age having originated roughly halfway between now and the extinction of the non-avian dinosaurs, Lake Baikal is actually considered an ancient lake, and according to the most common consensus, it is the oldest lake that is currently sitting on Earth's surface. There is one other contender in eastern Kazakhstan whose age is estimated at around 70 million years, but the lack of evidence for Lake Zaysan still favors Lake Baikal. So far, we've covered that Lake Baikal is the deepest, most voluminous, and also the oldest lake of the planet. But there are actually many more peculiarities about the Pearl of Siberia, where it is so different from the typical lakes, which we'll have a closer look at in Chapter 3, Oddities of Lake Baikal. A large catchment area and hundreds of smaller streams are continuously feeding into Lake Baikal, with these inflows making up 85% of its water budget in a typical year, while the rest is covered by direct precipitation onto the lake. Once the water enters into the hollow, it has a typical residence in the lake of over 300 years before the average molecule gets flushed out again through its only outlet, the Angara River. In this time, the water is exposed to the harsh subpolar climate of Siberia and undergoes a distinct annual cycle. Starting in deep winter when Lake Baikal is covered with a solid slab of ice, the water temperature at the surface hovers around freezing and then gradually increases to its 3.8 degrees Celsius at a depth of around 200 meters. As spring comes around, the ice masses on the surface slowly recede and the upper layers of water quickly heat up. At a certain moment in early June, the temperature distribution throughout the entire lake homogenizes at around 4 degrees Celsius, during which time the oxygen-rich waters of the surface sink to the bottom of the lake, supplying all stratas with vital oxygen. Once summer is in full swing, the temperature stratification completely reverses, with the surface measuring averages of 60 degrees Celsius, while the lake layers below 200 meters remain at a chilly 3.8 degrees. This annual recurring pattern, with two complete water exchanges between the surface and the lake bottom, has ensured a robust food web to exist within the lake, in which copepods create a self-cleaning ecosystem, and in which no one species of algae can blossom too excessively. These filter feeders, which are even devouring plankton when the lake is frozen over, together with generally low levels of phosphorus and nitrogen, actually create some of the clearest water in the world, with total dissolved solids only contributing 96 milligrams per liter of lake water. For reference, the World Health Organization recommends levels below 500 for drinking water, and the US tap water only average TDS levels of around 350 milligrams per liter. The low turbidity also allows for exceptional views into the lake while it's frozen over for nearly half the year. With a typical ice thickness of 1 to 1.5 meters or 3 to 5 feet, it is completely safe to traverse the frozen wasteland even by car during peak winter. The combination of rapid freezing and harsh winds on the ice surface also creates some mesmerizing formations across the surface, ranging from methane bubble columns to pedestals for rocks and icicles, which has propelled Lake Baikal as a winter tourist destination in recent years. During the summer, the interest of tourists shifts more to the mountainous surroundings of the lake, which has over time been protected more and more. While the Soviet Union wasn't particularly known for protecting their lakes, looking at what they've done to the Aral Sea for example, Lake Baikal has been treated way better in the past century. The first nature reserve of the entire country was set up in the northeastern shoreline around the delta of River Bagotsin in 1916, and many more nature reserves, national parks and game reserves followed the coming century, which now protects over 50% of Lake Baikal's shoreline. Despite all these efforts, however, economic prospects are continuously challenging nature preservation. So far, local and international activist groups have successfully rerouted a proposed oil pipeline along the earthquake-prone shoreline of Lake Baikal, whose leakage into the lake could have detrimental impacts on the biota. Further, a pulp and paper mill, which has dumped production waste and bleach straight into the lake for nearly half a century, has been closed since 2013 due to bankruptcy. And while the 15,000 tons of toxic waste which has been dumped into the lake dilutes well through the vast volume, some changes through the last decades have been noticed. The expansion of putrid algae and the disappearance of several endemic fish and sponge species are a byproduct of the local pollution, but also the general warming of the climate and lake water, which throws off the intricate ballet of water and sediments. How global warming will further impact these developments cannot be said right now, but one thing is for sure. The fragile cycles of flora, fauna, and the water itself have stood the test of time for 30 million years now, and the lake will not disappear anytime soon. The question is rather how the beauty and magnificence of this Siberian giant can bring prosperity to the region without damaging it, and how it will adapt to the future that lies ahead.